But please understand that a kind of table that you see here, you're going to see a lot. And we're going to add 2 more rows to it. Later on, I'll explain. So please try to get used to it. You can change to something else if you'd like. You can use a different table if you like. But this will be of tremendous importance later. Okay. This table. Okay. Something like this. So we plugged in the function, and for each value of the temperature, or the temperature in Fahrenheit and degrees Fahrenheit, then I get the distance, 115 if it's 0, 75, and so on and so forth. Okay. I'm just going back to the function one more time just to make sure. Yes, it was 2x. It appears to be a little, the distance in feet based on the temperature at 32. Apparently it's much longer. I'm just thinking about the numbers that I just got. Oh, I didn't mean to stop sharing. I meant to go back to the book. Where is my book? Right here. Okay. Interpret the meaning of this slope in the context of this problem. So the slope, can anyone give us the slope? That's part B. Can anyone give us the slope of this? Did I lose everyone?
Yeah, there was bad connection.
Okay, sorry. So can anyone tell us the slope?
Which number are we on?
We are on the same function. We haven't finished.
Oh, so
So
okay,
yeah, so this was part A,
2.
and now we are looking at part B. Yes, the slope is 2. If we don't put the measurement unit, we cannot get any credit. The measurement unit of the slope, so let me stop for a second because this is extremely important. The measurement unit of the slope is, or consists of 2 measurement units. The measurement unit of the top over slash the measurement unit of the denominator. So every time we talk about the measurement unit of the slope, you have to give me 2 measurement units. One coming from the top per over slash the measurement unit from the bottom.
So 2 over 1.
Measurement unit.
Fahrenheit?
But it's the rise over run. What is the measurement unit for the rise?
2 over 1.
What is the measurement unit for the rise?
Degrees Fahrenheit.
But this is the x value. I'm talking about the rise, right?
Oh, and that's y. So that would be the distance.
Feet.
Feet, yes.
Per
sorry. Degree.
Fahrenheit. So please understand, without this, 2 does not mean anything. It's exactly 2 feet per degree Fahrenheit. What does this mean? It means that as we increase the temperature by 1 degree, the rise or the distance increases by 2 feet. As we increase the temperature, the air temperature by 1 degree Fahrenheit, the distance increases by 2 feet. So it's always rise over run. Rise means the y value. The y value is measured in feet. Run means the x value. The x value is measured in degrees Fahrenheit. Do we all understand this?
Yes.
Okay.
And can you repeat one more time, please?
Which part?
The rise over value.
This is the y value, which is the function, is measured in feet. This is the x value, which is the x variable, which is measured in Fahrenheit, degree Fahrenheit. So rise over run means feet. Oh, measurement unit for 2 is feet, 2 feet per degree Fahrenheit.
Okay. Okay. It's basically same like y2 minus my y1 by x.
It's the y value over the x value. So we interpreted the meaning of the slope. One more time. For every degree Fahrenheit. Oops, sorry. For every degree Fahrenheit, the distance increases by 2 feet. Explain why the domain should be restricted to the interval negative 57.5 and 32. Let's just simply plug in negative 57.5 and let's see what happens. It's probably 0. The distance cannot be smaller than 0. Okay, so when I plug in here, or I can simply graph it. So let's do we can plug in. I can plug in negative 57. It's pretty sure. I'm pretty sure negative 57.5. It should be 0. Yeah. Because when you move 115 and divide by 2, that's what you get. So that's the reason why it cannot go below negative 57.5. Good. That's pretty much all I wanted to say about this, unless you want to work on another problem. If not, I would like to continue with the last section. Any questions? Please always remember, please bring to class any question that you encounter. Oh, and just remember one thing. Yes. So I promised to show a graph like this. Let's say x equals y squared minus 4, something like that. I did not show any example like this last time. So let's suppose we're asked to graph this. Well, as you see, this is not y equals. If I have y equals x squared minus 4, this is a piece of cake. I have x squared, and I pull it down 4. Done. No, this is a totally different situation. Because I have x equals y squared minus 4. I still have to find the x and y intercepts. When x is 0, I have y squared minus 4 equals 0. And we talked about this equation at the beginning of the class. So I have y equals plus or minus 2. But not because the square root of 4 is plus or minus 2. It's for another reason from the left-hand side. So I have 2 points right now. 0, 2. And 0, negative 2. So that's the first thing. Number 2, when y is 0, I get y equals 0, x equals negative 4. So the point I'm getting now is negative 4 comma 0. Notice that this is not a function. This is a parabola that either looks like this or looks like this. How do I know? Because if you solve for y, then you have y squared equals x plus 4, and you take the square root and you get two pieces. You get one piece with a positive square root, and you get the other piece with a negative square root. So this is not a function. It is a parabola, but it's not the parabola that we are used to seeing. This is called a conic section. It's a parabola facing either right or facing left. Okay, so let's plot what we have. Yes?
Excuse me. Can you explain why now you say that y equals plus or minus 2?
Yes. It's exactly what I said here. When I solve the equation, x squared equals 4, I apply the square root to both sides, and I get positive 2 and negative 2, but not the square root of 4 is not positive 2 or negative 2. The symbols come from this side, from the square root of x squared, which is the absolute value of x. It's not x. Is that okay?
Okay, yeah, my bad. Now I get it.
No worries. I make mistakes, so please keep an eye on. Even if there is no mistake, I'd rather go back and check if there is something that you notice and maybe I don't. Okay, perfect. So 0, 2 is this point. 0, negative 2 is this point. Negative 4, 0 is this point. As you notice, so it's this kind of parabola because I know that this is the axis of symmetry. How do I know? Well, because these are symmetric and this is the x-intercept. So the axis of symmetry has to be x equals 0. In other words, if I fold the graph with respect to this line, I will get the same thing. I will get those pieces overlapping. So here it is. Has to be as symmetric as possible. And I have to write that this is x equals y squared minus 4. Very clear. The domain is negative 4 to infinity. Very clear. The range is everything. Negative infinity to infinity. So I didn't want to forget to show that in class. Okay, so before I forget, because sometimes I do forget, so R.3 plus R.4 with 60% for Wednesday in my lab math, plus the written homework. Okay, all this is due before class on Wednesday. So now I would like to at least start the last section of this chapter, which is R.5, which deals with nonlinear functions. So it's a long list of nonlinear functions. So the quadratic function, I think we already talked about. So, and the quadratic formula, we refreshed our memory. Let me refresh our memory again here. Ax squared, because we did it during the study group, so I'm sorry. So the quadratic equation, and it has to be exactly in this order, descending order, equal symbol 0. And then the quadratic formula will be negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this is the quadratic formula. Now the graphs, I think we already discussed about that. Polynomial functions, we're going to discuss them in detail. And let me just give you some idea. So the quadratic function one more time looks like this. It's symmetric with respect to the y-axis. So y equals x squared, and this is called an even function. Has nothing to do with even numbers. It means that it's symmetric with respect to the y-axis. It means that the function at negative x, if I replace x by negative x, I get exactly the same thing. And this is the condition for an even function. Now, other polynomial functions, I'm just going to present the cubic. So this was quadratic, of course. I'm going to look at cubic and the fourth degree. We're going to discuss this in detail when we get to graph them using calculus, not algebra. Okay, a cubic function is a very interesting function. Looks like this. Notice that here it doesn't look like this. It's not a straight cross. It's a slow cross, flat, and then up. So y equals x cubed. And this is the cubic function. And this function, so maybe I should write here, this function is symmetric. W_RT with respect to the y-axis. And this function is symmetric with respect to the origin. Okay, it's symmetric. W_RT with respect to the origin. And what is the condition? Very similar condition for what is called odd functions. Has nothing to do with odd numbers. This one is called even. It's symmetric with respect to the y-axis, and this is the relationship between f of negative x and f of x. For this, it's opposite. F of negative x is the opposite of f of x. Very similar. It's just that this one has plus for even in front of it, and this one has minus for odd. And finally, just the fourth degree. So let's say f of x equals x to the fourth. It's very similar to this square root, quadratic, sorry. But it's not like this, but it's flatter here. Slow. It still has only one intercept, but it's much flatter than x squared. X squared looks like this. And y equals x to the fourth, flatter at the origin. So these are polynomial functions. And rational. Very important function. We have to remember this. And please tell me whether this function is odd or even or not symmetric. So this is y equals 1 over x, the simplest rational function. Is it symmetric or not?
Is it odd?
It is indeed odd, meaning f of negative x will definitely be the opposite of f of x. Looking at time, I know I have 3 minutes left. So I would like to also, there is the absolute value function. Yeah, let's list those. 2 more functions. Absolute value. It's f of x equals the absolute value of x. This is also remembered as a v function. And here's the graph of the absolute value of x. These are the basic functions, simplest possible for each category, from each category. This is y equals the absolute value of x. Odd, even, or not symmetric?
Even?
Absolutely. It's an even function, symmetric with respect to the y-axis, which means that f of negative x will not change the function. And just one more and I'll stop. The exponential. Although we have a chapter that deals with the exponential function. So let's look directly at the natural exponential function. Let me write the whole thing. Please remember these graphs. We're going to use them and we're going to refer back to them. So here is the exponential function. It crosses at 0, 1. The natural exponential function. Odd, even, or not symmetric?
Not symmetric.
Very good. It's not symmetric with respect to the y-axis. It's not symmetric with respect to the origin, so the function is not symmetric.